Hello and welcome to this lesson on linear systems. We're looking at the topic of systems of linear equations. So to begin with, let's review with a couple different linear equations. For example, y equals 2x minus 4. And then let's look at another one, y equals negative 3x plus 1. Okay, what I'd like to ask you is, do these lines, these are lines, right? These describe two different lines. Will they intersect each other or won't they, if you were to graph these? So take a moment and think about that. Well, it should be clear that these lines actually will intersect each other somewhere. Let's look at a few of the properties of these lines. So we recall that if we have a line of this form, y equals mx plus b, where m and b are just some numbers, m would be the slope, and we call b, or we can also call this the gradient, right? It's the other term that we use. And b is the y-intercept, right? Where the line would cross the y-axis. So in this case, we have an m equals 2 and a m equals negative 3. Remember, the gradient tells us how the line is increasing or decreasing. So unless these two lines have exactly the same gradient, they must intersect somewhere, right? If they had the same gradient, they would be parallel lines, and so they would never cross. But clearly they're different, so at some point, somewhere, they must cross each other. Okay, let's graph that. How about you take a moment and think about where that intersection would occur. And now we'll graph it together. So this first line has a y-intercept. The b is negative 4, right? b is negative 4. And for this one, b is 1. So for our first line, b is negative 4, we would come down 1, 2, 3, 4. This is the y-intercept. And it has a slope of 2, right? So if you remember, that's rise over run is how we calculate, how we think about the gradient. So that means we would be going up a value of 2 and over a value of 1. Okay, so we have a point there. So we could actually graph our line now, right? All we need is 2 points to graph a line. So if I were to draw right through those 2 points, there would be our line, and we could extend it in both directions if we like. So looking at our other line, we have a y-intercept of 1. So it would cross the y-axis right here, and it has a slope of negative 3. So that means we'd go down 3 units and to the right 1. Okay, so actually we've already found our intersection point. It's right there. So let's draw that line connecting our y-intercept to this other point right there. Okay, so there's our intersection point. We're going to be interested in what this actually means in terms of applications of systems of linear equations. All right, let's consider one other case. So this time, let's say our equation is 2y minus 4x equals 0. And our other equation is y equals x over 2 plus 6. All right, well, in order to graph these, it's probably more convenient to write them in the slope-intercept form. So we're going to want to rewrite this by bringing all the x's over to one side. So first we would have 2y equals 4x. All right, and then we can divide both sides by 2. And so we have y equals 2x. All right, so clearly this line has a y-intercept of 0. So it's going to intersect the y-axis at the origin. So we can put a point there. And it's increasing by a slope of 2 units for every unit of x. So that means let's change our grid spacings now. So let's say that this is 2 units. There's 2 units here and then 4 units and so on. So that means we're going to go up 2 units and over 1, up 2 units over 1, and so on. So I could actually put a dot right there. And let's draw our line again. So in this case, I could even start from down here and pass through both those points, like so. All right, so now for our other line, a y-intercept of 6. So we're starting here. And what is our gradient this time? Well, that's equal to 1/2, right? We are multiplying x by 1/2. So we're starting at 6. That means we're going up 1 unit and over 2 units. We would be here, and then up again 1 unit and over 2 units. Okay, so we are intersecting our graph right there. Let's draw that line. And if I wanted to extend my line back here, I could go all the way from there, like so. This might be describing a business. This might be your profit function. And this might represent your expenses. So in this case, actually I should change the term here. Profit, we're going to say revenue. Let's change that, revenue. What's the difference between profit and revenue? In this case, revenue means how much money you're making, but it doesn't account for any money you might be losing. Profit would be how much money you actually make when you account for your expenses as well. So we're not going to be talking about profit at the moment, but it's a good reminder to make that distinction here. So in this case, maybe we are selling glasses of lemonade, okay? So on our x-axis, this might be the number of glasses of lemonade that we've sold, and on our y-axis, this is how much money we're making. So that might mean that we're selling each glass of lemonade for €2. So for every glass of lemonade, you make €2, right? So you can see how many glasses you have here, and you go up to the value of y, and that's how much money you have taken in for those glasses of lemonade. Whereas your expenses now, again, x is still the same x. We're using the same name here, so it means the number of glasses of lemonade. But you might be losing, in this case, €0.50 for every glass of lemonade. Well, you have to buy the lemons after all. And you also have some initial expense, €6. So that might be just to get set up to buy the glasses that you're going to be using, or to paint your sign, etc. So your initial cost would be €6 just to get started, and then for every glass of lemonade, you're losing, again, €0.50. Okay, well, what happens when these two lines intersect each other? This intersection point is known as the break-even point. And why might that be the case? Well, it should be pretty obvious, right? You're breaking even, meaning that your revenue and expenses have now equaled each other. So what happens for x values greater than this value? Well, that's when you would be making a profit, right? Here you have a profit at this point. Any point after here, any x value, you're going to actually be making money now, because your revenue is growing larger, faster than your expenses, right? So if you were to subtract the amount of money that you're making, if you were to subtract the expenses from the amount you're making, your revenue, you're going to have a positive result. And so you have a positive profit. Of course, that's what you want. If your expenses were growing at a greater slope than your revenue, well, clearly that would not be a profitable business for you. All right, so that's it for this lesson.